Let's see. All right, I think we're live now. Just make sure everything's muted. Welcome back. Today we are going to be doing a data pipeline in Go and Queue. We're going to be using the Queue's DAG processing engine called Flow that powers the Queue command. And we're going to be working on Cuetils, which is a package in CLI for doing operations on structured data such as diff, patch, pick, which takes out an object based on another object, match, and some other things like that. We'll see them in a minute. And what we want to do is add a pipeline where you can string these together that can form the basis of a tool which enables ETL pipelines to be more easily written and composed using Queue. In addition to the Cuetils structural functions, we're also going to be writing a helper that calls APIs and trying to pass all of, or maybe perhaps we'll just pass all of Queue's libraries that you can use in its tool and the Queue command through to our pipelines. And we'll use the same. We're probably going to copy the code out of Queue to implement the dependency checking that automatically infers the DAG of your pipeline. Anyway, with that, let's get into the code. Let's see. Can I pop this chat out? Yes, there we go. I can minimize that. Cool. All right, I think we're ready. Almost. Just need to get set up a little bit more. All right, here we are. This is Cuetils. Let's pull it up on GitHub. Cuetils. We're looking at this project here on GitHub. And if we look at this, we can do Cuetils. And you can see it has a bunch of commands. The ones we're interested in are, you can count how many nodes are in an object, depth of an object, mask, patch, pick, replace, transform, a bunch of different functions for working with JSON objects or YAML. You can actually diff JSON against YAML with this tool. Let's take a look at some of these examples real quick. We'll probably look under test. And we can look at something like diff. If we diff A and B, there's an extra C, one less B, and another extra B, and you can see we get the diff structured into our output object. And then the patch is the reverse of this. You do something similar. We start here and we end up with the other. And you see here we're just running Cuetils diff. Let's see, an insert will add in various objects if they don't exist already. There's a upsert that will insert and replace. There's a replace that only replaces if it already exists. It doesn't add new stuff. Transform is pretty much standard Queue. You can do a lot of transformation in Queue. Mask filters a sub-object out of another object. So here, we're going to filter out A, B, C if it's an int, and D if it's a string. So B will be filtered, C will, and D will. And then, not patch, pick. Oh, I have a lot of picks. So here, that's the same object. I think what I want to show is when it doesn't match. Yes, we're not getting this C. I'm not sure why this B is not coming out. That ought to. If we don't have a bug in there. Oh, because we're doing things up here. I forgot. A lot of this is testing out the CLI rather than pick itself. Here you can see diffing JSON against YAML. And you should be able to get output in JSON, YAML, or Q. This is the Q output, which is the default. Anyway, what we want to do today is, we'll just call it pipe. Let's see, ST series. This TXT is these are essentially files. And then this is like running a command, and you can compare stuff. This is called, comes out of the Golang compiler. They have a cool testing, so you can just write more tests in text files. They're super easy to contribute. And these will always have to be Q. Yeah, that's fine. Normally you might, we'll talk about reading files later in this. So we want to be able to do something like step one is, let's go like X. I should have kept some of that stuff around. Let's get some other data. Let's do pick, because there might be maybe there's not an issue here. Maybe we're only, so we want something like Y is this, X is this. Maybe we want to do something like P1 is, I haven't thought about how to, maybe we should use the same format as, let's pick up Q having it. X and P. So we do something like hashtag X to X. So that's our normal, that's our starting object, and then we're gonna pick with P, or Y in this case. Let's at pick. Coming up with examples is going to be the more challenging part. let's do something like this to describe. We could do just something like the result, we're picking A, B, C, and D. So we might just want the C here. We're going to mask out C. And then M2, we might mask out A. And then let's do, which one? Do R1. Actually, let's upsert these. So essentially we'll get the same object back. Oh, we want to upsert Q, yeah, okay. So in essence, what we're doing here is we're going to have P, well, X and Y. Should make sure we use spaces. And those are going to feed, maybe I should do it. I mean, we probably don't need the comments for now. Oops, we can get rid of them later. And these will feed into P1. And then that'll be M1 and M2. And then we'll have U1, right? So we have some starting, oh, wrong mouse. We have X and Y we're starting with, and we're going to pick Y out of X and start with P1. And we're going to mask it twice in two different spots, and then we'll combine those back into U1. And we form this DAG here. And the idea is that you should be able to specify something like this. And our tool should be able to infer this DAG out of it and properly run it. So it will run P1, then it can run M1 and M2 in parallel, and then it'll be able to run U1 once those have completed. And the tool flow engine has something like this built in. And we're going to leverage that package. It's let's take a look. You can find it under Tools, Flow, and this is the stuff we're going to be looking at and using. Although we may not need to go into this as much as I think if we go to the Go API and then look at the flow engine, we can have custom workflow stuff. So we're going to be building a custom workflow on top of Qflow. Essentially, lets us define our own tasks and how they're identified and what happens. We divide or we decide what and write what the implementer is, or the implementation of a task is. And Q should handle all the dependency checking. So let's grab this code and I just want to, maybe we can just do example. question is, we do have a pipeline command already. Question is, I think we have flags. I think we get rid of this argument for now. So this is so Cuetils uses Hoff code generation, and it's using the Hoff mod CLI, and that's coming back here. Ignore these; these are to be more detailed help commands. And we have a generator, and we're using the Hoff mod CLI gen and schema. This is our schema here. We can actually clean this up a bit. That's no longer needed. Typical CLI stuff, name, package. I mean, for Golang, there's a package. Usage, a short description. You can have a long, we're just repeating it. Has commands, has flags. These are persistent flags. This uses the Golang Cobra CLI package. And so there's flags that persist through all commands. And then there's a lot of flags. There's some stuff about how to do a release. Has the ability to check if it has updates and can fetch and install that update. You can enable pprof if you need to debug commands. And then there's just a bunch of commands, very similar stuff. They have args. Sometimes they have multiple. A lot of these take a series of globs. Just these are the same entry points as the Q CLI. And in that sense, we just gobble up the rest of the inputs, maybe having something beforehand. A lot of these are two operation commands. So the CLI will allow you to pick across directories of files. So you can pick the same object from bulk JSON or YAML or whatever, or just a singular. It supports standard in as well. So that's just a digression into that. Now what we should be able to do is we can look at Cuetils, and we want to do Cuetils by not implemented. Okay, that's as expected. Why is it? Oh no, it's there. Okay. We can make this a little bigger too. So we're going to go into command. And so this is the implementation of the command. I didn't have to write any of this. I just wrote, well, let's do this. Let's go back here, and then we can look at this. This right here was sufficient to generate this file and hook it into the whole CLI. None of this code is written by me, or sorry, none of this code is written by me. What we'll do is we can look at You see, we just comment out this line, and then we can just call our own functions. I don't believe so. What we're going to do is just copy all this. And just clean this up a bit. I like to keep standard lib separate from third party, separate from internal, or this module type imports. Okay, but for that, there is no code. And what we're actually going to want is, do we make a dir for this? No, we haven't. Let's call it. Well, let's probably gonna have a run.go. Just get some boilerplate in here. Oh, why is it saving so long? Sometimes the I think the Go packages like format when not the run behind the scenes take longer. We're probably gonna have tasks.go. So let's start with func run. That should return an error. Oh. That's probably okay. I think we will want to do something like that and reuse the. Maybe we'll just remove the or move this into like a utils package or something at some point. But for now, it's fine. And we want to come into here. I'll just grab the same function and see what this looks like. Should probably move that definition as well. Oops, wrong func file. This is the one we want. No. This is the one we want. We just want to call this run. And then we're going to want some more. Where's our load happening? Am I thinking of? Yeah, okay. Load globs. Func run. Something like this. I'm not gonna have that. Not gonna have that. something like that. Be right back. There we go. I think we should be back. I should check my audio. All right, it's going. Last stream I did not have audio on. Okay, so we're just kind of setting up some boilerplate just to make sure things are going. So what this is doing is we're just bringing in our command line args and the flags as options, so that we're just reusing the same data structure. We're gonna read the args. This sort of like breaks down. There's some like extra format, more than just globs. You can specify some extra things on it. Oh, and it determines, I think, if it's like Go or JSON, or in Q or JSON. And so you can sort of intermix these things. And then it's, I think, actually doing the whole loading it through Q into memory at this point. Why is LV not being used? Where was it used in pick? Or was it? Maybe we need to look at common. Oh, that's the left-hand side value. We don't have that. That's why I'm confused. So we don't even need that at all. This takes care of loading those globs and all that. And then for each value that's in that, this is where we're going to find tasks and then execute. And let us bring that up in Cuetils so we can copy and paste it over. Code, Go API, flow, custom. Let's just bring this over. So let's see. If we come into here, it's just gonna, yeah, okay. Tools flow has a couple of things going on. Let's see. Oops. rid of that. So we're going to have a config, which looks like this. There's the brute. Okay. We might have to mess around with this and figure out how this path is working. Yeah, this part is interesting because it will only run tasks that are involved in the output. Yeah. So the main thing for this is a update function, but this is just the config that gets put into flow.new. So flow, we're going to pass a config, our sort of root value, which in our case will be the value we're currently looping over, or maybe we'll just use the top level one. And then task factory. So this is the thing that finds, sorry about that. Let's see. It implements the runner interface, which is, I think the things are probably misnamed a bit and can be confusing. So this is the same new function. We have this task func that returns a controller. And let's see, a controller doesn't have any fields. It's mostly managed by queue. Let's see. Runs a task. All right, let's see. And then we can make custom tasks. So if I recall, this is the best way to start. So this essentially gets a value, does something, and then fills that value back. And then task factory gets a value, and if you find something that you want to call a task, in this case we're looking for things with a field foo, then you can create a task from that and return it. And the cool thing is that you can have custom data in your tasks, and you can fill that in based on other aspects. You might just decode this whole value into, we'll probably end up decoding the whole value into a Golang struct. In this case, instead of looking up fields, looking for those, we're going to look for those attributes that we wrote before. The pick ones, we're going to have an API, and then we might have, maybe we'll call it app flow, so that we can pick up on, or maybe we'll call it app queue flow, and then have some value in there that tells us which one it is. I'm not sure. Those, let's see. Let us see if we are going to be able to package tool. Let's say like exec. Let's see what exec.go has. It's all lowercase. So this is where we might have to copy some of this out, or we might just end up writing our own. Because we don't have access to be able to do this here. Anyway, we're not using any of those. We want to try and just get some semblance of a thing working. We'll leave this for now. I think in this case, we will need, this is our task, so, right, this is our task file. Just gonna move this over so we don't lose it for now. Let's make this big again. Get rid of all of this. Get rid of that. And then we're gonna have yeah, maybe we'll be specific about, well, yeah. I think we'll make specific tasks for each of these types on the left. So we'll have pick. And I think we need something like, yeah, we should be consistent. X is a Q dot value. Y is a, P is a Q dot value. And then result is a Q dot value. If you like longer names, sorry, this is much more Go style. And we're going to keep these uppercase so we can, we might need some like Q, something like that. I forget if this, you can do this, or it's the other way around. I assume it's this way. Oh, so we don't have a custom task. And then we're going to have pick task, which we'll call pick. Maybe we'll just call it P. Yeah, why does, I think, yeah, this run is a function that takes a task and an error. Okay, these are dependent tasks and what they. Okay, let's do this. Let's get our runner. Maybe we'll call it factory, since we'll leave that because it doesn't really matter for now. And then do is really going to be in run. Let's just put it down there for now. Where is this context used? Is it not? What's it in here? Okay, maybe it's just left over. But I think we do. We need to be able to pass this around, I think. We'll see. Did we? Okay, we can get rid of custom then altogether. Let's call this pick task. And then we're going to do that. Maybe we'll just return error. We aren't gonna exit early yet. Okay. Let's make this a queued out value. Let's just return that for now. So we might. We'll look into that more later. We just want to do val ops. All right, so we don't need this anymore. I don't think it's going to compile, but Oh, come on, import some stuff. Oh, probably need to start here. Custom task. Oh, all right. Let's just comment all this out. I don't think we have D anywhere. We don't need that. Okay, run to go. Too many calls and to run. What? Big value. Okay. We might as well. Because we are going to want to provide better context. So we go value. That should suffice. Why is that on 35? Wait, is that right? What is it talking about? Oh, and for now. Let's just see if what's context used here? There's the queue context we don't want. Test pipe. Very cool. Pipeline 61, 21. What? Oh, that's okay. Pipeline 14, 29, 50. This is 29. Custom flow pipeline. So we get here. Running. And then we want so we want that there. Do I have? I don't think I have a command for that. Let's make one. CI. Let's make one. CUI. Okay, it's Cuetils. It's under Q. Oops. So we should be able to do CUI. Cool. Now we don't have to change directories. That's a jump file, by the way. You should be able to find the concept on Hofstadter.io on GitHub. See the links below, I think. So you can find it through one of them. Anyhow. Tagging, running, okay. So then, what can we look at? Does the controller have any functions? Yeah, we can print the tasks. Let's just, for the sake of argument, dot print nil. Okay, so let's go up here. There's nothing in vowels, huh? Let's see. It's not expecting this to. What is going on with this? Oh, right. We should do cube def. Oops. There. Okay. I mean, it's reading the file. Why structural globs is not working? Did I not? Oh, maybe we're not. Let's see, load input. Okay, it's coming here, right? Read globs, read arg. Maybe it's not. Wait, we're loading. Where's load globs? Okay, we read it. Read file. Okay, so load globs is not outright. Does. Because this is really like a mix between. Maybe we should just do read. Parse input, load input. Maybe this is what we actually want. Yeah. Load globs is lazy on the queue evaluation. Is what it is. Maybe we should rename it that. And if we look at what's happening is, or was happening, if we look up here, all binary op globs is where everything is happening. That's under common. So the left-hand side, which is typically a singular value used across all of like pick or mask or replace, update, all whatever. We read that in. Arguably, these should be named the opposite, but it is what it is right now. we're not going to worry about that. We fully process the arg that's going to be used everywhere, and then for all the right-hand operands, we're just going to load them into memory, and then you can see we're compiling for as we loop over them. We'll compile them and then call our function on them. So in this case, we assume arg, the left-hand side is typically a single arg, but there is a read globs here. Which loops over them and reads them all. So this should, in theory, fix our issue. Okay, so pointers, so we're not copying. What does it need? Queue contexts. Oh, what doesn't it like? Oh, we're still gonna have X nil. Is that gonna work? What? Oh, duh. Forget what language I'm in sometimes. Okay, let's see what happens. Okay, that's cool. This is relatively expected output. Dagging. Okay, so we can come back here and get rid of that, that. So there's our task factory. We don't need. I think maybe we do want some stuff here. No, maybe we'll just leave that in the output so we don't have to keep referencing it. It'll be at the beginning. And then we want to look at factory. So then we need adders. We might be okay for now. There's a, actually let's, we need to make a reproducer for Q. This one. Okay. So we'll take a brief detour because this will show you what attributes are, and there's slight variation in the problem we're having. GitHub, touch, what issue number is this? 1458. And back here. we only need that much, probably. Actually, let's get 2 levels. And what we want to demonstrate is the difference between what do we want to call this? I'll just call it and at my tag. Actually, I think what we're actually looking for is something like this. In that sense, we may not need this either. I think. The hell's any? So this is a field attribute, and foo is a. Maybe we should just do this. Oops. Decal field. That's their attribute type. They're slightly different. This one's embedded inside of a struct, and this one really applies to label A. And declaration attributes can survive through unification. They'll be joined in that. They'll like carry through, whereas field declarations will not, and that's by design. So in order to make this reproducer, we're going to read the input. We don't need any of that. Format print line, print f %pound v value. Let's just make sure this works. I get. Ooh, I don't have a. How do I put this on here? Oh, where do I have something like that? Give me 1 second. I need to possibly look at a file with things that might have sensitive information in it. Okay, yeah. This is a jump file, if you haven't been around to hear that. This just makes writing commands and jumping around the terminal a little bit easier. Although there are also functions where we jump into a directory, run a command, and then jump back out, or push and pop. We're using that. So all this did I wanted to do crgh, like right here, so that I can jump into, if I go cr, we jump into the Q repo directory I have for scratching out code when I'm helping people on Slack or on GitHub and I need to just like write files locally. This is where I come up with a repro case or I hit a bug. And so there's a bunch of different stuff in here. So if I want to, we need to, so I didn't have this command, right? crgh doesn't work. Cr does, but ignores the gh. So c edit edits the jump file, and then I can reload the jump file. So now I can go crgh. Oh, crgh, and we'll go in there. I could go cr hack. And all we did was, beforehand, this is a common pattern I like with this @ sign. We had this R here, or you can spell out all of repro. And it was just this before, but if you just attach this on the end, it means you can supply like an argument afterwards, and it does that. Anyway, so let's go. No, 1458. Get out of here. It's already reloaded, so let's go back. U is one of these things that goes up a directory or up n number of times. RGH. Okay. Go run 1458. Error declared but not used. Where's error? Oh, whatever. Let's just make sure our code works. It runs. Okay, we're seeing the value we want. Now we want to. So this issue. We don't need. Actually, let's come back. There is a thing called attributes in Q. They are unevaluated markup that Q at least parses and provides semi-structured back to you. It's really just strings in a map, or not technically a map. I have a thing to turn into a map. We're going to see that shortly. Basics. Where do I have something on attributes? Okay, yeah. Something like this. These two, this same kind of code. And you can have comma separated values. You can do things like this. Just to show you an example, here's some things on how it propagates, yada yada. What we actually want to do, there's this attribute kind, and the problem is essentially these two functions behave differently. They want, if we look at this issue, the singular version only handles field attributes. So you have a function which returns all attributes, and you can actually choose which kind you want. You get one or the other or both. And then you have attribute which returns it by key. So in this case, you might pass in like foo or cow or protobuf. Let's get back. Yeah, it's this part right here is the key, and then all of this is the value, except that Q will break that value down a little bit more, I believe. Yeah, you can look up things by key within attributes. I thought there was a... Yeah, you can just loop until there's like nothing left. But this I thought we updated this so that you could look up. Okay, num args, raw arg. Yeah, you can get the raw. So you can pull it apart yourself. So we want to say where did our D is going to be... I don't want to spell this out every time. Val.attribute decal. And then F will be val.attribute field. Like this. And I expect this one to be non-existent. But then we can do val.attributes. Let's go format that. Where are we going? Value dot attribute. Okay. We can just format printf. Printing like this will give you extra information. We're going to format a go type a bit. It should print the struct with its key, the key and value names of a go type. And then for comma, we need to put that on the other side. We want to %d. We might need to look up A first, but we'll see. Where'd our terminal go? Yeah. All right. Value matter. That will get both. Undefined value. Add tackle at field. So D F A. And then that's not what I expected. Where did I hit this? I don't remember where I hit this. Hope I didn't have 1458 before. Oh. Stop. Why is there a vendor in there? is that? It's probably, oh, this is old. It's still using Q runtime. That was probably from similar or repro around. I don't remember where I was having this issue. We'll let it sit in case we can come up with it again. Well, I don't know why. Print line will be length of that. Oops. Did we make sure we have the latest Q? Yes. Oh, I was making coffee. I got the. I'll be right back. I'm gonna go finish making a coffee. I'm back. Got some good coffee. Freshly ground. And freshly hot. Okay. There was an issue, but it doesn't seem to be happening. Okay. But I don't know why this is 0. Let's take a look at that real quick. Okay, so this is what we're getting. I'll go back and say we're printing that first value. Let's do this. Print the first value A, which has the value underscore, this and this. Then we're looking for attribute decal. Wait, what? Where are D and F? Okay, that's these here. Never mind. I thought there was extra object going on. So it's printing these two, but then it's not getting any attributes here, which is weird. Let's try this. And we'll do, make that a capital A. And then we want just make sure I just get to the top. I know how to use it. I just want to see its return. Okay. Val equals val dot lookup path q dot parse path A. Let's see if this changes things. What? Oh, you don't need this anymore. Okay, that's interesting. This is what we want to put on that issue. Okay. Cool. I'm glad we found that. We'll just update this. Q v0.4.1. And in Q, show you this. We have this thing called reproducers, and it's the idea that you should be able to copy and paste this one section, and it should show the correct output so that we can turn it. It turns right into a test. That's what essentially. Oops. Yeah, we do want to go back. What we need to do is produce file. These text tar, they're called. So this is essentially a tar file. This is a file in it. This is a file in it, and this first section is special. You can exec commands and you can compare standard out and against a file. You can compare files against each other. There's a bunch of stuff you can do with it. I'm not going to go into that, but in Q, we like to create these as part of this. So what we will do is name this main.go, and then we want an exec go run main.go. We want to compare standard out to golden.standard out. We'll make it txt. Yeah, it doesn't matter. It really doesn't matter. Okay, and then down here, we're going to have golden.standard out. If you want to use this for any of your stuff, there is actually a Raj Pepe. Oops. Go internal. You want this repo. And there's the textar C to create it. One of these, you just give it a directory and it'll spit it out into a file. Then you get tx, this will extract one of these files into a directory. And then I believe test script will run it. Hoff actually runs these as well, I believe. I haven't done it in a while. Let's see. Let's go back here. So our golden standard out, and then the attributes call on the, oops. Actually, I should do what actually printed. Hey, Robotic, what's up, man? How you doing? My OBS is not connecting to chat. I need to make sure. Where's my mouse? That's what's going on. I have two computers overlaid on top of each. Oh, I'm still in. Darn. Let me. Sorry. Let's get back to the code. I'm sitting here. I do still new to streaming. What am I looking for here? I'm looking for this, so I can remove my background and not be so in the way. So how long ago did you join? I can tell you what I'm doing. I found a bug in Q, or what I think is a bug. I don't know if I mentioned Q on your stream yesterday in chat, but Q is qlang.org. It is my most interesting language, up-and-coming language. It's a better JSON, better YAML. Maybe I did say this, and whatnot. I use it for the basis to a lot of my tools. And I think it's going to eat the DevOps world up. But pretty much anywhere you use config and whatnot. It's made by the guy who wrote the prototype of Kubernetes before. Well, I guess Borg is the predecessor to Kubernetes. Borg was the internal version of container orchestration at Google before they open source. Some people came together and wrote an open source version of it with a refreshed, like refactoring API. So Marcel, who created this language, he wrote the prototype that then became Borg later. And he's a PL guy, and he wrote or was highly involved in all the configuration languages that go along with a complex container orchestration platform. Essentially, like it wasn't YAML that like we feed to Kubernetes. It was Borg config, and then later it was GCL, which is general configuration language, not Google configuration language. And those were both object-oriented languages, because really you want a language on top of your configuration once it gets complex. Anyway, this helps you write like better configuration and be more confident about it. Born out of like Google scale problems like Kubernetes and whatnot. And what I'm doing is I got this value here, and there's these things called attributes, and we should be able to pick them off. I'm like looking for values with attributes by walking the Q tree, or I'm letting Q do it, but I'm looking for values with specific attributes because I'm trying to build a pipeline where you could say like, I want to take this value and pick this out or diff it against this. And it should self-assemble the tasks that need to happen in a DAG so that it executes them in order, but can do parallel automatically where needed. But there's these functions. I have this value here, and well, let me get the output real quick so we can see the output. And I'm printing off the value, and then there's two ways to get attributes. And so on this value, I use one way and I get it back. But if I use it the other way, I get 0 length here. But then if I look up this actual A and get the value, look for these attributes, I do get them. So I'm having an issue. It's off by 1 in the tree in one case. And so I'm trying to add this, what we call a reproducer in the Q community. You just should be able to just copy and paste and run it. What did I do here? Wait, I don't know what am I looking at? I need to come down here, paste this. What actually printed is what I just actually pasted, but what I expect, is lowercase a, lowercase a. And then I need to come back up to the top. Versions of the function. To have an off by 1 in the tree height error. I think that's essentially what's going on. Let's preview this. There's our input. There's note the first attributes call. I expected the first attributes call to read. Oh wait, yeah, the expected output should be this, I think. But maybe not. Maybe they should be the same. Something's off. I'll add that. Attribute. Let's put these highlighted. It seems like looking up a uh, I'm actually not sure what the second attribute's call should return. Let's provide some options instead. Should looking up a return the value? We would only get the at decal. When we look, does at fields apply to a label such that when we return at the lookup path, it is lost. Should the, well, I spelled that vicinity. It seems add decal should return in calls. I'm not sure. Maybe decal shouldn't. I mean, I think intuitively, I spelled it wrong. Intuitively, is that right? Yeah, okay. It seems there should be I want to say like mutual exclusion, exclusive. Attributes would return either type. Not sure where fields decal I want to say whether field should always return to get together in the where something like that. Hopefully they get it. I think I just want to say by I'm referring to the A versus A output to do that. All right, I think we're good now. Okay, so does this present a problem to us at this moment? I think it was because we're trying to run this code here, which I might have drawn down here, this code in the txt format, txtar. We got an x value, we got a y value in terms of q values. I guess we didn't do anything with z. We were going to mask out a z. And what we're trying to do here is we got a task P1. It's going to pick y from x. And then we're going to pass P1 to M1 and M2. And we're going to mask these like inline objects or values out of P1. And then we're going to upsert M2 into M1, which means we're going to add any values that are not there and overwrite any consistent values of the same type and get something. And so we haven't explicitly defined dependencies between these, but Q should figure that out for us and make a little diamond for us. And what we're trying to do is we're writing the custom task task runner, and we have a task factory which Q is going to pass us this whole value here, and we're trying to find these guys here, or really these things here. I don't think I need this anymore. And so we're trying to do that up in here. And let's go back and see where our code is at. Let's see, tests, pipeline, Cuetils, pipeline. Okay, so we're getting everything to the end. All right, so there's our printed value. Here's where we're turning that into a DAG, and then we would run it here. And I believe Q supports like, okay, we've only found these tasks so far, and you run something, it fills something, and there end up being more tasks. So it will like, I believe it should, based on the output I have here. No, flow engine, that's what I'm talking about. I thought based on this, we should see TF multiple times. What are we? Is there? No, look. You should probably make sure this code still works. Oops, I didn't want to exit. I want to come over here and okay, it looks like it does. That's good. That means something is just off in our code. Oh, we don't. I don't. Oh, wait. What? Oh, no. Never mind. FN3. We can get rid of this now. And I'm going to go into run. And this is sort of where this code begins here. But in this case, we're going to. I wonder if this is why. No, I mean, it is getting to. Oh, but no, maybe the. Let me just uncomment this. Oops. I can type here. Let's do this. And let's, for the sake of argument, tasks. And we should go into here and let's just see what. Come on. I think I want to just get this back in here. Undefined adders. Okay. Let's just write it now. Adders equals val attributes. I'm still going to complain. Oh, wait, is it? Oh, right. Q dot value adder. Is it singular? Oh, I don't have it here. What was I just looking at? Adder, okay. Could just go for it too. Pipeline. I wonder if DAG works. No, it doesn't. I wonder if I just need to update the library. Yes, this is what we're doing. Okay. It looks like it's pulling them out. I think what was happening before is we weren't specifying the root, which means Q is going to choose its own. And I believe the default for that is instead of tasks, commands. And I bet these are just not printing as nicely because we used a different print function. So what do we do? Get that out of here. This can go. It's our task factory. Okay, if it doesn't have something, we just return nil nil. I believe Q will walk at that point. or it's probably walking anyway. Let me see. So we need to loop over the adders, the attributes. Let's say whole words. I can, I swear. Yeah, I just need some more coffee. Okay, so for each of these adders, let's try to is adder is known adder. I suppose if length of adders 0, we can just return nil, nil. I think we do want to have this. And then if a known adder, we essentially want to might just want to construct it all at the same time. I suppose if it's we want more should there ever be more than one known adder? I don't think so. That would not seem to make sense to me that would be the case for the time being. I'm just wondering, like, do we need to switch on the type of adder? It's pick, diff, merge, whatever it is. We need to do something and essentially return the correct task here. So we need a function. Let's say maybe just maybe task. I think we need val to q dot value. Adder will be q dot attribute. Oops. I think we want this here. I think we want the same turn nil, comma nil. Here, I'm gonna take this down here. Do a switch on the adder dot. I think it's key. Not. Name. There we go. Okay. Case. Heck. guess we haven't defined what this looks like. We're going to need the val will be val. I think that's it. It will have to pick it apart. No pun intended. We're going to have to decode, extract, look up paths within this value. In particular, maybe we'll do that in the run so we don't do it here. Yeah, I think, is that, where did we define this? Pick task start. XP, this will be ret. And then val will be queued up value. Lots of queue values. We're just gonna save these because we don't care about optimization of space right now. I should probably not have the comments like that on my tutorials website. Let's see. What am I doing here? So maybe task. We want to just return this. That should be sufficient. And then we'll make 3 more for now. Let's see, we need mask and observe. We should probably replace it here too. Come on, get rid of all those. Mask task. Mask. Good enough. And then we want these should be consistent with the queue. This tool I'm building, there's a command to it, but there's also a Go package that you can reuse, and we're essentially using this Go package. But there's also essentially, where's Peg? I should stop saying essentially so much. There is pure queue versions of these. It's more of a academic experiment to see if you could do something like this. One of the interesting things about queue is that, excuse me, that you can't program in queue of sorts. There's no recurse. It's not Turing complete. You can't have functions or recursive calls, sort of thing. For loops are actually comprehensions, and ifs are technically what we call guards. It conditionally includes this in a in your configuration, the way Q merges all the things together. Check out the logic of Q, or just check out tutorials if you're interested in Q and the future of configuration management. Here I write a lot of DSLs in Q. The Hoff tool that I built is purely we were using YAML and we replaced it with Q, and it's been such a great choice. I use it for like GitHub Actions. Actually, do we have something like that here? No. I could show you that another time, perhaps. Let's see if we can find our different task types first. Anyway. These are our tasks. We want to go into run. Where am I doing this? Factory. Insert, and then insert. Okay, now we were printing something in TF. Is that TF? We have prints, printing the attributes. We want to do maybe task, val, comma, adder. Oh, we need nil, 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 default. I guess we can just, they're all returns. So if we get here, format that error f. We should probably just warn for now. Because people could have, we want to ignore attributes we don't know about generally, because that way people could use attributes from different systems in the same queue file if needed. And maybe we'll throw one in just to see what happens. Call this no. Let's do that. This should, in theory, oops, did not mean to close, meant to save. This should, in theory, work. We should see some improved output. Oh, I didn't. Where is that A being printed? Let's get rid of that. We don't need that. And then we want to go into these tasks. Are we running? Well, oh, well, perhaps that is why. T comma error equals that. Turn nil comma error. Oh no, you know. I know. This is what we want. If t does not equal nil, return t comma nil. Now attributes of interest. Interesting attribute in all matters. This will. I don't think we're gonna worry about. Maybe. I wonder if you could. I want to try it anyway. This is what I want to try. Here, let's copy this to 2. These should be ideally functionally equivalent. We should be able to. We're going to do it on multiple lines. Oh, this gives us a good chance to do this. This is an upsert. And we're essentially nesting some of them, at least. Let's do that. We don't need we won't need this here. So we're gonna pick X from Y. We don't need Z. What happened here? One, okay. That's that. And we want 1. I want to get rid of that. There. Okay. We didn't rebuild. Okay, we're getting it now when we're running. Okay, we see that. Let's see what happens if we run the second one. Yeah, see, we're not descending. We would have to probably write our own custom stuff for this. I think somebody might have requested for nested task support. We should. I'll have to look. Let me write that down. I swear I'm going dyslexic. At least in my writing. Okay. So that second one won't work today, but this one should. What does maybe okay, so I think there's this problem of where does the result go so that when we fill it back in, it should be included. This is I've worked on this problem before in the context of if you're familiar with Docker, 3 gentlemen who created Docker initially are working on a successor to Docker called Dagger, which is almost doing exactly this, except instead of writing pick mask and whatnot, you write use components that are meant to take an application from source code to deployment. So it encompasses everything from like your CI pipeline and like needing to build containers and like how you build multiple dependent containers and to like when you're deploying something with like Terraform, you have certain resources that depend on each other. And so if I update this one microservice, what does the entire DAG path look like to get that code into like staging and then production, like put these controls in place? And how can I specify that in a single like queue file, more or less, by importing modules I can reuse? And then the cool thing is that based on your code changes, Dagger should figure out exactly the minimal set of tasks that need to happen in order to make your production look like uh, it looks like this. The idea of Terraform, you change something and Terraform only makes changes necessary. Imagine having that come all the way back to like your Git diff and be able to, in a like a mono repo and having that Git diff in there determine what happens. Super cool stuff. Dagger.io. I had the chance to help them out for a couple of months, maybe 3, when they were trying to figure out this pipeline and get it like the first version out. I helped them out with that a bit. Dagger.io. I don't know. Yeah, let's see. I have access. They hand it out like candy. It's really like limited by how many people they can add to like GitHub, effectively. Docs.dagger.io. See if they have a cool example. An artifact. So it builds on BuildKit, which is really they're using 2 DAG engines in one. It's crazy. It makes for some fun logic in the code base. But you can do things like this. And so it's kind of like it's all CLI open source, so you can essentially run like the equivalent of GitHub Actions from your local machine. Everything builds in a container, and it does ideally the minimal amount of steps necessary. They're not compiling code here, but we could look at it's not bad because they're using the same. I wonder if Universe is still in here. I'm not sure it is. I wonder if I have access to other stuff. They may have moved all those like AWS, Kubernetes, like Golang, Docker, all those sort of modules you can build on top of. They might be in a different repository now. I'm suspecting. I think I've seen some things about that. That's just going to be Go code. Unless it's like under. Okay. Okay, so maybe this is their plan. A Dagger workflow to develop Dagger. Cool. This is their self-hosting this. So import Dagger, which is probably like this Dagger artifact. It says you have some source code, and what's cool is that this input could be like your local directory. It could be a container. It could be a GitHub repository address, and it's all in the same. And you can, I think, specify that at the command line. And they have a test step here, doing unit tests. I'm not sure if they're actually using this, but this expresses the idea. Then you have build. We build it. They're probably copying it out here and putting the build log out somewhere. And then you can package it up into a container. Instead of writing a Docker file, you write something like this. And you can like reference the results of this previous stuff is really just a container layer. This container's all the way down if you didn't know. Um, and actually each stage, there might be multiple layers in there, but you can reference a different, uh, essentially build artifact in a layer. There's some so Docker is actually built on the same thing, build kit, Moby. It's all Moby now, but Docker is essentially build kit's the actual thing running Docker build when you build, and Docker only uses like 10% of the capabilities of build kit. Like it doesn't have this automatic DAG resolution, so that you can like only build what's necessary, only update the layers that are necessary, and understand that, and a whole bunch of other things. So essentially, Docker is just a front end to BuildKit, and Dagger is an alternative front end to BuildKit. And they're adding this extra stuff on top of like what Docker is to express not just like what containers look like, but what like environments should look like. Um, and essentially, since everything's running in a container anyway, and BuildKit can just run containers in a DAG, like with a DAG solver, then you just like run commands in containers rather than like building a container as well. So there's some cool stuff you could do with BuildKit besides just build containers. Anyway, that's we're not using BuildKit, but we are using the same Q task factory or like DAG processing engine. Okay, so we're back here. And so what we need to do is we're going to have, like Dagger has this, which is probably why it came to mind, but there's like tasks are really a map of some object, and they're probably just they're going to need an outfield, which could be anything really, although it will probably be a struct. Maybe we define it like that, but we probably keep it any in case we just want to like output just a number as like a scalar value rather than like a complex value. So these should each. So what's happening is like tasks. This is the power queue, right? I've now said that tasks has this matching. This is actually called a pattern constraint, because you could do things like for all fields that start with an M, apply an out. Then only M1 and M2 would do that. And these two specs of sort are merged together by Q using its logical evaluator engine. This is like you can do things like if you're doing Kubernetes like things, so resources, whatever it may be, set their labels to something. You could set labels across a whole bunch of configuration. Makes building composable configuration pretty easy. If you ever found yourself repeating the same values across a bunch of different Kubernetes resources or YAML or JSON, like Q is definitely worth checking out because it's actually a JSON superset, which means all JSON is valid Q, but not all Q is like valid JSON. Like obviously a key without quotes is not valid JSON, but come on, these two, this task and this task is the same. Let's just go back. I don't want to do that though. All right, I need to get our pipeline back open because we want to look at these tasks. And, well, actually, we just added that. In the definition, so are you talking about? What do you mean no outputs? Oh, I wonder Q eval. I bet I have a syntax error. Yeah. Wait, why is that? I had a syntax error in that, but the important part is that the concept is possible. I don't actually. I want all of them. Cool. Now you can see this out is injected everywhere. Oh, we're just repeating ourselves a lot. It's part of P1. It's not everywhere we need it to be, though. I don't think, is it? Oh, yeah, because this is the example that's not nested or and whatnot. So that's fine. Okay. So now let's go to our task. Let's implement the task. Fill a value. So we need x is going to be p dot val. Oh, I wonder. This is where I don't recall the necessary like semantics of this workflow engine since I worked on Dagger about a year ago. We are printing the incoming value. Okay, it's only associated with the current value. That's pretty cool. And they have the out. And we are not printfing. So let's do that for at least this one. Oops, wrong thing. There we are. Where'd it go? Why did I lose it? I should just be typing it. Actually, come on. I have this issue with copy and paste and NVim. I'm actually on a Chrome OS system. And so copy and pasting between Linux and the outside world, like a browser, has been, say, hit or miss. That's probably the right way to describe it. There is now a working Wayland compositor-based copy and paste that works. But for some reason, NVim, like, if I do something like that, I don't know. Yeah, it throws this, like, and then the next keystroke is sometimes ignored. Anyway, I digress. We want to see both these and if they're the same or not. Did I just queue val again? What am I doing? This is what we want to run. Pick val. Okay, there's X out and Y. Pick task has showing more. Oh, it even has the ellipses. Wild. Okay, so really probably doesn't matter which one we use. And which means we probably don't even need to store this on there. We probably don't want to store that value, truth be told, because the Q flow engine is going to give us the most recent version of the value. Because what we're going to do is, like, when we get our answer, we're going to do val.fill. What the hell is this? What is next? Oh, okay. I think. Oh. What does fill take? I'm in the wrong package. I need to go to tools flow. And fill takes an interface. Oops. Let's go look at this code real quick. Go value to expression. We'll see it in the next one where it shows up anyway. If we did something like result equals map string. Hopefully we can do a q dot value. No, it wants a go value. That could be troublesome. Because I don't want to necessarily have concrete results. Well, let's see what happens anyway. What is convert? Where do we go? Why am I losing this? 376. I'm gonna go to this. What is this? Okay, types, internal. Maybe it does accept the value. So what we could do. What are we doing over here? I think we're filling in a map. I'm not sure about the, see, we're kind of having to construct a map that has the same lookup, but I think if we do that and we set res out, capital out, equal to our picked val, then we fill with res, we should probably be all right. And then we need to do x is going to be lookup path q dot parse path. Oh, it's going to be hashtag x. And then we need p. And then we need r equals structural dot pick value x comma p. This is close. Go dot dev Cuetils. Okay. Where's our index? Oh, we need directory. Where's our subdirectories? Interesting that it puts that under there. We are looking for pick from ops. We should pick some default ops. So this should actually be let's look at it in GitHub or in Vim. Wait, what? What are you doing, Vim? Okay, we're looking for ops. Is that the only place we use it? Just for some extra errors when we need it. Okay, we don't need to. Now the question is, what happens if it's nil? There's probably a problem in a number of places. If ops is nil, ops equals. What I really want to do, so this is not going to be the same defaults as that would come in through the CLI because Viper, the parent to Cobra, is going to apply some defaults we put to flags. I think this will be all right because op node errors is going to be false. So a boolean will default to false, and that's the only one we're using. So for now, what I'd like to do is update the HOFMOD CLI to create a function that returns a default filled in of this. Because I just want to drop nil in here for now and all these things without having to pass in the flags or import flags again and whatnot. Oh, it's almost time to refill the coffee. So this is going to be R. And we need some curly braces here. Right. I mainly use some pointers and reference, and thing, the ampersand that turns it into a pointer. Mostly just for some, actually, excuse pass by value. I want to pass in the pointer that gets copied in so that I can modify the underlying structure. If I just passed in a non-pointer, like when I change these flags on the way out, it won't work. Or it won't be reflected on the outside the function after it's called. What are we doing here? We're running this thing. Okay, right. We don't have val anymore because we don't need it. So actually, let's update all of our things to be that way. The other two should be fine. And then not the problem. Nerd tree's confused. We don't actually have any custom data we need with these tasks currently. So this should be all right. Said task.go. Right? 32. But returns do. Is that right? Yes. Probably never return error, I don't think. But we'll see. Okay, so we should see out be filled in by the actual pick here. It should be, oh, I can't see here. Here's our, let's get our test code out so we can compare. So we're picking Y from X. Is that right? Should be the other way around. I think it should, honestly. So what we really want to say is we got this data here, and we want to pick out a sub-object A with a B that's a string. So any string, it doesn't matter what kind. We're going to pick C if it's an integer, and we're going to pick D only if it's capital D. So you can have this, what's cool about Q is you can have this intermix of type definition and actual data definition. And you can do things like only see if it's, and it's also greater than 10. You could do something, and we'd only pick I if it's that way, or C if that's that way. And that's called a constraint. So you have Q has this idea of a lattice, types and data and values all live in this, like, you can think of it as like a graph. Let me just show you what this is, because that's one of the cool things about pick is that it can work like that, and you have pattern matching as well. I want a picture of the lattice, which is going to be documentation, the logic of Q. So you can see something like a struct with X and Y. Well, an empty struct is like X is just adding to that, Y is just adding that. If you bring those two together, this is probably a lattice. It's going the other direction. There's there's top and bottom, which is like any and like nothing or null or error. And then there's all these things that live in between. So you have like number, int, specific things bottom, but you also have comparison is in there, which is between like an abstract number and a specific number. And bool true and false bottom. And you can do things that you conceptualize like structs or types and values as that. So in the case down here, we have like a type to a constraint to an actual piece of data. You could think of this is just the type of it, and you could imagine having. Do they have something like this down here? Yeah, where you have top, you have a int, then a is 1, and then and then a and b is int, and you see how these things kind of like get more specific, and they can you could combine a1 and b int and be somewhere in between here. Is probably like below this one, but before this one. And then of course there's optional and defaults and a whole bunch of other crazy stuff that what you do in Q is you write down like configuration, and Q tells you whether it's valid or not. And then now it's got a Go API, so we can build tools on top of that engine. In addition to this like DAG processing engine that I'm working on with right now. So okay, I digress. But that's like pick is designed so that we can use that, like a string matches any string versus like I could do anything like that's how you do it, is like this is like a regular expression. So anything that now this could be like do or don't or doodle, it would match it every time. So there's regular expression matching among other things, and we're doing some structural matching here. And so we want to see, are we not printing enough here? Is that the problem? Right, because we aren't printing it sufficiently here. Oh, there's one of those. Come on. You want to delete. Upsert. Now let's see what this looks like. Not much more helpful. I was expecting more. Let's go back to, where's pick? Let's get X here and P. I don't think I should. Yeah, because this. Oh, maybe this is my freaking problem. Val is a value. I'm filling a value, not a task. Where is this? So then I should be able to get what I want without this map, actually. Because I believe I'm using an outdated code for Q. We should have fill path, I think. Yeah, fill's been deprecated. So, hey, I see that, but I don't. Where is it? Lord Raiden, thank you for the follow. How are you doing tonight? Do we need val equals that? Or do we just need... Let's do this. Before we go changing that, let's just change that to D. Let's see what happens. All right, okay, this is what out looks like. But we're not seeing it over here. We have underscore def. What? What was it? Okay. I think I know why it's printing that. Maybe. Maybe we can just get rid of some of this. And we should probably... Where's res? That's probably this here. Okay. Is that what it was before? Is that there? Yeah, it looks like that is the object. I should probably get some curly braces in here. I should probably actually do... Oh, okay. Do I have that here? I don't know if I want to do that. Why don't I have a print function handy? Here. That can probably be deleted. Unless somebody wants to use it. That's, I think, why I left it around. I can probably use this function. Maybe I can't. That is... Maybe I should change this to... I don't know if this will break things, but... It probably will. I think what we'll do rather than change all this. Let's just take this function over here. Wrong format. Okay, now I want to do format queue. Ah, but right. I guess we should probably. It's good to catch your errors. And this can, formatting a node can produce an error, so. Foomt error. And then we'll just print S. And oh, that was in mask too. Very okay. Where were we doing this here? Put it there. And then turn on more printing. Let's do them all. Cross our fingers for compiling. Hey. Love it when it compiles. Okay. There's our pick task. Out is any. What are you talking about? Interesting. This is valid queue syntax. Essentially what we wrote before. This right here. You could, this is called an embedding queue. You can write the same thing as, well, oh, I don't want to do that. Like whatever you write in something like this is embedded in. So I mean, I could do who is a int and then just write foo here like that and just leave it just like that. And then this would, you can think of it as this being substituted. And then since this is an embedded struct, like if this was bint, you could look at it like really as a 2-line struct like this and see how it's like, let's get some extra. Where's my cursor? There we go. Is this the one we're using? So we're looking at this part here, and we're just mapping this equivalent statement. Like we're using foo as a substitute to map this in, but what I'm showing you is that it's now embedded. We started with foo, now we don't have it. We just inlined it sort of. And because this doesn't have a label like this, we're gonna take away that and that. And then these would just essentially be like copied in, more or less. So that's why this output showing up here. That's this, we're mapping this out, so it's not as evaluated as something like Q eval x1. It's been like processed through in this case. And like these references here being pulled in line as well. So you're getting some nesting of it. So really we could look at it as this is the true task we need to run, this U1. And there's out there. Okay, so getting back to this. Let's make sure we're current. Go here. And okay, we want to look at pick task. There's our X and our P. There's our outs. We're not seeing any of the extra stuff though. Why are we only seeing out? Let's try val equals val dot fill path. Q dot parse path out and R like that. And then maybe we could try d dot fill val. Oh, not one too many there. To bug out, which we could do gambas. That would be fun. Does my channel even have like Twitch points or whatever they are that you can collect by watching more and more? You know what? I'll be right back too. I don't know if that was recent. Let me just go to the away real quick. And if I don't remember to put this back when I come back, yell at me in chat because I'm just getting back into this streaming thing and I forget. No, I didn't. Cool. All right, back. Um, let's go big for a second. Speaking of like, ooh, I hope that wasn't too loud. Speaking of channel points, I don't know if you're like Minecraft fans or whatnot, but there's this super cool mod pack, an SMP, and like Twitch kind of phenomena going on, in that some hardcore Minecrafters built a mod that allows you to interact with the game through Twitch stream. So like when you use channel points or donos or gift subs and things like that, it affects like they get things in the game. And they wanted to essentially build a mod and a mod pack where they they can give something back to the people who support them in game. And it's this it's called Vault Hunters. Super cool, like Iscal 85, Pizza Hut, um, Captain Sparkles, and like Zine or some of they're the four that, oh, and H Bomb. They're the five that play the most. But it's a super interesting like Twitch API interaction that actually like works with gameplay. Um, I guess I only mentioned that over Twitch points, and I'd like to like be able to, and they like do gamba, so you can like gamble points and like earn more points, and I'd like to be able to do that with like maybe like programming or something like that. You know, can we program something in such amount of time? Gamble your channel points, make fun developer oriented channel point usage. Like, you know, another fun one might be like spend 10,000 points to like kill a pod in production, something like that. All right, let's go back to the screen. Robotic, are you streaming later? I don't know how much longer I'm going to be streaming. Don't know if you are going to be. Okay. Maybe we'll have to look at who we might raid. I want to just see. We didn't see it out there. I'm just trying to like. I want to see like the output of this and the input of the next place. Oh, you know what might be? I might know what's actually going on. It's not the code, the Go code. It's the Q code. This should be. This is how we do, what do we call, like function like stuff in Q. I have a page about this in here under useful patterns. There's this function pattern. We put double quotes around it because really you're just you have some sort of function transform. In this case, we have like something called in, and we have something called out, and we can do things to the middle and whatnot. And then to call it, well, technically you would do something like that. This is a slight variation on that theme. Essentially, you can think of this as like the function, and this is or is that right? And this is the arguments. Is that right? Yeah. So our in is actually another complex object of message raw and count 3, and that's why it prints raw 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 after like turning the message into upper and then joining it count times with a space, something like that. So I just need to put the results into the actual. Otherwise, we have these. I don't know if these. I might. Well, we'll find out. Let's find out. I want to know if the attributes still show up. Is what. Why didn't? Oh, because my mouse is there, and I have this part of my hand hits the touchpad. Let's try this out. Okay. Didn't quite work. I guess. Hmm. What we actually want, I think. Dot out. What if we do it this way? Because then you can, in theory, produce multiple like new data. Outside of there, you're in Australia, aren't you? Robotic. I think I remember you saying that. As I recall, your accent definitely leaned that way. I work with another number of people in England from time to time, so I'm not always sure if it's English or Australian. Let's see if this works. Bum, bum. Nope. But maybe it is, because maybe we're not getting enough information out of those tasks that we didn't implement. We aren't doing this. We don't know if Phil's working. Because I know that this isn't necessarily ready yet. I might have to go like remember through the Docker code. Anyway, we might see it on X or P down here. Oh, we missed some of the code. Not that much. It's gonna be you. It's that one in quotes. Oh, maybe that's why. Yeah. Switch. Okay. Let's see. Here's our pick task. We aren't printing the results, but if we look at it, this is our X. We're picking out A, and B, and then C2 and D. Okay, so it's there. Let's see. This is cool. It might be working. didn't need the map. Much preferred to stay in queue. So now we need this. And then I feel like this is the point where I'm like, I'm going to refactor this to turn this into a switch statement again. Or maybe I take the switch statement from here and put it in here and have like a pipeline task. And then we can just switch on the, because almost all of this is exactly the same, except that we need to know what to look up. What are we doing here? This is mask. And this should be upsert. Oh, we need to fix these things. This should be, we need to look at some docs. Where did my docs go? I think some of these are like inconsistent with how they go. We're gonna upsert this into that pick. No, they are consistent. This is our new data into there. And then this needs to be, we're gonna mask out of X. Very good. I think, let's see. We'll have to trace the output and make sure it looks right, but our upsert right now is empty because we printed the arguments to mask. So we're going to mask A out. We're going to mask C out. Then we're going to merge them back together. So we should see those arguments, and then we should see probably this. I'm expecting this to be the result of upsert. Maybe we should print R here just for good measure. Okay. Moment of truth. Yes. Seg fault. Oh. Wait. Upsert. Mask. Oh, structural mask.go. 86. What if This is not correct. Let's see what happens if we fill with R. This may be like a concurrency issue in Q. You can't like access values at the same time concurrently. I know we were dealing with this in Dagger. And they had just put like locks everywhere. And what I don't remember is if we had to carry the context around on all these things, where it stands today. Q will be concurrency safe. There's a roadmap for that, but there's some other optimizations to make that easier. Like Marcel, the creator of Q, is rewriting the evaluator this year, at least the first half, and hopefully by the end of that, it should be a lot easier to make it concurrency safe. Let's see if we can. See, they're both starting at the same time. So let's just see if we do var lock is sync dot mutex. And we do lock. I think it's just lock. Let's look it up since I don't remember off the top of my head. Golang sync. All right, Robotic, you have a good one. Thanks for stopping by. I'll see you on your next stream, I'm sure, at some point. Yeah, okay. We just log, then we do a defer. Is this right? I think this is the right way to do it. Lock.unlock. I haven't done this kind of stuff in a while. But I figured this was going to happen. I don't know if doesn't look like the X is correct anymore. Let's go back. I think that was right. Wait, what? What is res? Oh, I don't want to go back that far. What even was this? Yeah, okay. That's why I'm confused about the first occurrence of it. Okay, at least it's getting there. Well, let's go look at this function. Because maybe it's just mask that's not working. What? Oh, right. I should have just gone straight to the air. Because you know what it really is? It's this thing we did here that we didn't repeat. Let's put these at the beginning. And we need it for upsert. And so if this works, I think we'll probably call it good for the night. To do implement proper default helper func for we'll just do these three for now. Hopefully this works now. Okay, moment of truth. Did we get it? Nope. What's going on here? Okay. Let's get our task back. It could just be that we are not doing this. Pick our value, fill path, fill. Oh, hooray. I mean, kind of hooray. Are we going to get there? This R should have something. Yes. I think it works. Slightly in a different order. See, C is now after D, but not worried about that. Q doesn't care about order. They are equivalent values. I think it works. Should celebrate by drinking more coffee. Cool. All right. Well, thank you all for checking out my stream. Don't forget to like, subscribe, follow. These all go up to YouTube. If you want to check out old ones or stay, be able to watch them after 2 weeks when Twitch deletes them, they're up on YouTube always. I'm trying to upload. I'm also recording this to disk in higher quality, so hopefully the YouTube ones will be HD. And I don't know what we'll work on next time, but I stream most days. I'm still trying to find a consistent schedule, but I'm trying to stream most days of the week. Probably more on weekend. I work a little bit during the week. I work part-time during the week. But anyway, I will see you later. Until next time.